So I have seen that there is a transformation that is happening from a traditional vehicle. The world is moving towards software-defined vehicles. And this transition is happening that has enabled testing early. They're able to design, validate, and do the maintenance of, using the SDV. What are your thoughts why this transition is happening? If I can ask you, Dr. Dirk?
Sure. Well, about the why, I think because the world is moving so fast now. Yeah, so when we see the speed of innovation, I think in Germany, at least for the last 2 years, everybody has been talking about moving at China speed. So we really see how the world is dividing right now in terms of development, and certainly in that region the speed is set at the moment. And I think software-defined vehicles are a good answer to basically help meeting this demand.
Okay. What are your thoughts, John?
So I see two major areas coming out of this evolution of software-defined vehicle. One is the ability to get the intelligence out of the car and then make intelligent decisions and bring back in changes quickly, and hence the software-defined vehicle. The other part of it that's really driving what I see is personalization. When you get into your car in the past, all of us would make little modifications to our vehicle to make it fit us. But that's us doing something to the car just in the cabin. But now with the software, now you can have it start to learn about what your likes are, your dislikes. So when you are coming up to the car, you hit your key fob, it says, I know who this is. Look at your ambient temperature outside, start making decisions, what it has learned from me in the past. So that's where I see driving this.
Thank you, John.
If I might add something to
Sure,
that,
please.
The personalization actually is being leveraged by the OEMs to basically give them additional monetization opportunities as well. And this is something that I see driving a lot of this, especially in the U.S. Is if you look at the annual reports of most of the automakers, they all claim that within 10 years they're going to be getting billions of dollars from software-defined vehicle features.
How real is that, though?
Well, I didn't say there was a real path to this, but they're all making claims and they're all making investments in this, and they see a path to this. Yeah, we've certainly have had some failed ventures at people trying to do this, but Tesla has demonstrated that they're able to upsell certain software-defined features in here as well, and I think there are a lot of people who are chasing that type of business model, with varying levels of success, of course. But any path to that is being stated as being able to make money is something that people are going to chase after.
Right. I'm sorry if I jump in, right? But I think this is really interesting, right? Because this topic was kind of like top of the mind 2 years ago, right? And then we had the seat heating as a paid service debacle, and that has certainly dampened the mood. And you're right. Yes, Tesla, of course, with their full self-driving mode, that's a big chunk of service. I just last night I was sitting in a small Italian car, not the really fast ones, and the owner basically explained to me that they really now are charging for microservices, basically remote access, getting your battery level or so. And I thought it was interesting, like for him as a real customer talking about this, like, 10 euros a month, yeah, okay, I bit the sour apple and I just applied to this. But if you think about it, you're still talking about, 200 euros extra revenue. Think 10 years, so that's 2,000 euros extra revenue for a 30,000 euro car. That's maybe a nice margin improvement, but that's not the billions everybody's talking about, I would say. So for me, the big question is that really what we're chasing after, or is all of this not really a hygiene factor that helps you to sell the cars in the first point?
I think it's just a subscription point, right? To get the intelligence, the data from the consumer. And that is what the product is all about. So the OEMs, when they're doing this business model innovation, they're trying to focus to gather more data about the consumer, about their driving behavior, how they're even going to use the vehicle. So I think that all this business model innovations around software-defined vehicles has come with its own issues, like talking about compliance, looking into cybersecurity, how to meet the safety requirements. So John, what are your thoughts about it? Like from a cloud-enabled development, how we can manage compliance, safety standards?
So I was listening to this discussion, and what popped into my mind is, and I bet you, most of you have gone through this, there are technological waves, and right now, the SDV, it's young. I mean, it's immature. What we're all looking at is the technical details of individual components, and how do we put it together. So you're right. In my life right now, it's functional safety. Everything's about functional safety. How do you automate it, and how do you get it early? And this is where I see innovation happening at the engineering level, because we need to get rid of the manual processes and automate this. So running in the cloud, you can do this on virtual platforms. You can start checking, did the merge request I just do, not only did it go through CI/CD, we now have CC, continuous compliance. How did it, did it introduce any issues? But did it break your safety case, right? Any indications that you can get early that it's, excuse me, anything that it's doing.
Then let me ask you, so, when a lot of the innovation actually comes in from a completely different angle right now. So let's say it's about Angry Birds running in the car, right? And that is really far away from functional safety, I would argue. But let's take a case like, I don't know, like a simple smartphone app to open your trunk. So does the smartphone app developer have to be ISO 26262 certified? What about the cloud developer? What about the SDV developer who's developing the function on board? What about the embedded systems developer? Where do you have the boundary?
Again, that's why I was saying it's young. Because what we've been focusing is from the inside the car out. And it's interesting you say, well, Angry Birds is not a functional safety case. With what we are seeing when we're talking to our partners, with this consolidation of hardware, it's coming. So we have
functionally safe Angry Birds then.
We will have functionally safe Angry
I think
Birds.
we need to stay compliant when it comes to functional safety, right? We want the cars to remain safe, right, for people to commute. But you raise a very important point, which is, who is going to work? Is it the cloud developer? Is it an SDK? Or is it an embedded engineer? I always believe that one stack is something not sufficient, right? So all of the companies have to work together, automotive OEMs, the cloud, and the software vendors, they have to work together. So it's all about convergence that will allow the system to thrive and ensure that we are able to create safe cars that has the required personalization, right? So let's take an example that I want to drive, right? And the car recognizes me, configures the seat as per my height requirements. It configures and it knows that what kind of a mood I am in. It plays the music, creates that kind of an environment that I love to drive in, right? So such personalizations can thrive if the convergence of multiple ecosystems play a part. Bill, moving on, I think John talked about virtual prototyping. So from a virtual prototyping perspective, on cloud, how it is going to help the development of software-defined vehicles?
Well, it's interesting because virtual prototypes have been around for a long time. I know I've been doing it for most of my life in here, but virtual prototypes have traditionally been there for only the lowest level of software. You developed using a virtual prototype until you got your silicon. You dealt with the slow speeds and the partial modeling, and then as soon as you got silicon, you threw it away. It just wasn't fast enough or useful enough to do that. But the software requirements of SDV, as well as the lifetime requirements, for like the cybersecurity regulations in the EU, now mean that a virtual prototype needs to be used by more users because there's much more software to be done. And ideally, it's used for more of the vehicle, for the entirety of the vehicle's lifetime. If you look at trying to, check out your over-the-air updates and make sure that they're going to be continually working for the entire lifetime of the vehicle or 15 years after you stop shipping it, which I believe is the cybersecurity requirement, you need a good way to do that. And you don't want to use a parking lot full of cars as your CI/CD vehicle. So you need to come up with some way to virtualize that representation. And so by using a virtual prototype that virtualizes on top of an ARM server and leverages the native performance in there, technologies like ours are able to run at the same speed as the silicon, or sometimes even faster, enable these developers so now they can take all of this and move it out to the cloud and become that necessarily virtualization component, so you're not reliant upon, like I say, a parking lot full of cars to do your CI/CD testing.
Okay, so what are the limitations when it comes to virtual prototyping that is being echoed in the industry is about real-time optimization, how to optimize it for a real-time environment. So how to manage this? There should be a pathway for these companies to evaluate, create those test benches virtually. What do you think, John, about it?
So there's two ways to look at this problem. I always look at it is if your software has been written well and is good interfaces, good event-driven, what you're using virtual prototypes for is to make sure that functionally and algorithmically your software does what you expect it to do. Then when you start bringing it and of course in the virtual prototypes, the concept of time is, it's compared to us, but internally there's, it's no accurate clock. We're running it faster than fast. But when you bring it onto real platforms and timing is starting to be brought in, my own experience is that when we found bugs in that area, it turned out to be, it was actually bad programming, right? It was not, the virtual prototype didn't do well. And same with Bill, I've done this for a long time. And I've been honestly waiting for this day is where we now have, you brought up the parking lot full of cars. I instantly started thinking board farms. But then I went, hold on, wait a minute, a car? Think how many ECUs are in a car. So it starts to multiply. So now I can bring that all the way back up, do my testing in the cloud, spin up as many instances as I want, change my test cases, and then now bring it onto the FPGAs. Everybody has their little Frankenstein test boards, and then eventually in the car, you're never getting rid of any of those steps, but you're shrinking it. So.
Makes sense. Bill, do you want to add anything to it?
Sure. First off, I'll say that actually we maintain real time in our stuff, so we don't have a simulated concept of time. We actually synchronize to real time in here.
We'll argue.
It's a nice thing. It's the nice thing of running faster than silicon. We synchronize back up with there. You don't want to start doing your cycle level optimizations on here because we maintain functional accuracy, not the low level hardware accuracy. But from a timing perspective, when you're running AutoZar and you've got a timing interrupt to fire every 10 milliseconds, it actually fires every 10 milliseconds, in here in our devices. So that it is certainly delivering that in there. But I will say also, most of the bugs that we find are people writing race conditions in their software, in here. And since we're naturally multi-threaded, we tend to find them. It's interesting. We booted up the R52 Zephyr build, and by default, it actually has a multi-cycle race condition coming out of reset in here, which no one had ever found apparently. Nice. In here, so we upstreamed a fix in there, which actually is already in the R82. So you'd already found it. So I mean, virtual prototypes can be used in that capacity as well to help identify a lot of these things.
Well, thanks, Bill. Yeah, what about you, Nick? What are your thoughts on that?
Yeah, there will be skill set challenges, and there's a lot of training that's going to be necessary to make sure that, the developers are inputting the right code and doing that. So I think that's where we're seeing, from the talent side, which I tend to work with quite a bit. There's a lot of young engineers coming out of school that are really interested in this, and they do need to have the proper training to be able to not be the beginning of the problem, right? We have to have good solid code in these vehicles.
Yeah, thanks, Nick. Moving on the yes.
Well, I just wanted to add one point. I mean, when you mentioned multiple ECUs, right? So I think where it starts getting really interesting is if you look at time synchronization across all the elements running on board of a car. And there, from what I've learned, it's not about having like real-time virtual execution. It's okay to run things in slow motion, but then you have to have each node in the car running on the same slow motion level, right? So you need not only virtual ECUs, you also need virtual bus systems, and you need to synchronize everything. And I think this is where the fun starts, right?
It most certainly does. Yeah, when you start scaling up to that level and having, the multiple ECUs coming back together, which may be running at slightly different speeds, because they may be based on different processor technologies or even different simulation technologies. Since as much as I'd like it, we don't rule the world for all of the processors. There's still some done with others, so they're going to run at different speeds, and so you need to synchronize in. So, that's a challenge in the actual car, and it's a challenge in the virtual environment as well.
Yeah. So when you're talking about virtual environment, cloud, and SDVs, I think security is another landscape that has evolved. And it's all about, again, the security of the car, security about the information, the personal data of the passenger and everything. So how to manage it? Professor Dirk, what do you think that what OEMs should adopt? What should be the strategy to manage the security landscape of the future SDVs?
Well, I mean, we heard how important, of course, functional safety and security are. Yeah, that is a fact. Mm-hmm. But because the car is getting more and more complex, it is so important to think of a car, in simple terms, like a bento box, right? So we have certain compartments of the bento box, which have to be developed first time right. I don't know, talk about airbag or something like this. And then there are other parts of the car where it is actually okay to maybe take a more incremental or even experimental way of constantly improving the functionality. And then it starts getting really interesting when you have, in Germany would say Wirkketten, so when we have event chains that basically cross these different departments. This is where I was bringing the simple example of, open trunk. Right. So what are the different steps in this event chain, and which of them do you have to actually make safe, and which ones not? And I mean, obviously, yes, there is ISO 26262 decomposition and so on. But how many people really are able to master this formal way of looking at decomposition and mapping this to the complexity of software, and then even mapping software to, in high performance compute, maybe to mixed criticality runtimes and so on. I think this is where it starts getting really interesting, because it's the same thing when you're looking at the internet. There is no version of the internet. There is no common state of the internet. It's chaotic, right? So the more complex things get, you have to be able to isolate those things which are important, that you really have to harden from those things where you say, don't care. And I think that is really fundamental, that you cannot just basically put everything into the same bento box.
Yeah, thank you. What do you think, John?
So I was going back to your Angry Birds example from the beginning, and it's pretty close a few years back in the industry. I used to be in the IoT side of the world, and everybody said, no one is going to pay for security, but everybody wants it. And it was pushed off to the side. Well, then we heard about the hack in a certain hotel through a certain fish tank, and it became obvious that security has to be brought in, but it's not bringing in the technical bits. You have to bring it into your the way you think, the way you code. It's the same with functional safety. You can't just throw a bunch of standards down and say, meet this. You have to think about it every day. How am I going to do it? Where it comes into the code and the designs and the architectures that come out. And then finally, what I've been hearing more and more in the last year or so is everyone saying it's not functional safety and security. It should be just one word, right? Secure functional safety.
Excellent point, John. Thank you. Nick, from an IT perspective, right, a lot of companies are trying to work with the OEMs around SDV, the cloud. So what do you think, from an IT service perspective, that, how they can add value?
Yeah, I think that when you have to work with companies that, service providers that understand the space and that have been a part of it and have made the investments from the beginning. Well, maybe not from the beginning, but for a decent period of time here, because there are incumbent vendors that a lot of the OEMs tend to work with and the tier ones tend to work with, and you have to select the right one, and you have to put a lot of trust in there, and there has to be a lot of collaboration with the vendors from the outside, and it has to be one team. We do quite a bit of work with some of our customers, and we're an extension of their internal teams when we're trying to collaborate and bring all those points together.
Thanks, Nick. I think you raised a very important point when it's all about multi-vendor, multi-system collaboration as well. Bill, what do you think that how this evolution and how these forces will come together from a multi-system collaboration?
Well, I mean, and that's a fantastic point because, if you look at the traditional OEM tier one relationship, a lot of times the OEM would contract out to the tier one, deliver me this subsystem, et cetera, from there, and kind of wait till it showed up, and then you're getting subsystems from multiple vendors all coming together, and now you need to do the integration task on here, and SDV and just the constant drive for safety on this means you can't wait until you get the subsystems coming together to start performing the integration task. It's too late. You're going to be too late to market, et cetera, from there. So the ability to drive these things, to do more collaboration, to get those designs done earlier, and in many cases, at least a lot of the SDV conferences that I've been, you talk about the OEMs taking over some of the tasks for the tier ones and kind of driving some of that coordination themselves in here. But, at some point in time, it still breaks down to how do I get my entire supply chain to collaborate? And, this, of course, is where I say, well, do it all virtually. You don't need to wait for silicon. You've got the ability to have a, before hardware version of your hardware that you can now say, oh, you're all going to collaborate on here. You're going to establish these set of APIs, this safety interface, and et cetera from there. So, so by virtualizing the behavior of this, you can enhance the collaboration of your supply chain elements.
Okay.
That's one thing I'd like to get in on is when we're thinking about the cloud, and we've been talking about that great point about the integration. Integration now is probably the biggest problem in SDV, flat out. The technology, we've got fantastic engineers around the world. They're going to solve it. But how do you bring together multiple companies, which is all got to end up in one code base? So now we're thinking, multi-tenant Git repositories. Okay, that's pretty easy. We've done it in companies with multiple groups. But remember, a lot of these companies do not want source code to be seen by other companies. So now you solve, but again, it's a technical problem. You bring it together in the Git, and now the CI/CD/CC comes back into play. Virtualization, we run up virtual platforms. So you can see where this is all going. It's all coming together. Solve that problem of the integration effort.
Great point, John. And I think, Dr. Dirk, if I need to ask you, as John raised this point, right, multiple companies partnering together. So what do you see from a future perspective as a business model innovation? The companies will partner with their ecosystem partners together to ensure to build the standardization and integrated fleet of the software-defined vehicles, or something else?
Right. So I mentioned early on the Digital Auto Initiative that we've been building up with a lot of partners over the last 2 years, and these are exactly the questions that we're looking at there, right? So how can you actually manage this transition, which is not only a technology transition, but a real industry transformation, right? So we're basically seeing the move from, completely compartmentalized hardware software combinations which are tied together through the infamous Khan matrix towards, depending on the speed of the OEM, of course, towards central compute solutions where we then actually decouple hardware and software, which needs to start at the beginning. It's a supply chain decoupling exercise, of course, right? And then actually creating a loose coupled delivery model. So I think that's really important. So we need to be able to get organizations to work together at different speeds. So the evolution of mechatronics versus the evolution and speed of EE versus the high speed of everything digital. And then integration, of course, you mentioned. You still need to be able to compartmentalize this from an IP point of view, but at the end of the day, it's about interoperability. So at Digital Auto, for example, we're working a lot with the standards coming from COVISA, the Connected Vehicle Systems Alliance. They have created a semantic definition of vehicle APIs that I find very interesting. And when you're talking to OEMs about this, something that I'm hearing quite frequently is, how much standardization do they actually want? Well, ideally, I don't know, like 80% maybe, to get basically the commodity stuff and commodity functions out of the way, and then the remaining 20% where they want to differentiate. And then obviously from a tier 1 point of view, it's exactly the other way around, because for the 80%, a tier 1 can basically realize economies of scale. So I think that's going to be an interesting thing to observe the next couple of years.
Thank you. Nick, earlier in the conversation, you talked about talent development, scale, how you see that is going to orient, for the future market, around this area. Yeah,
I mean, this is where it's going, right? So the skill sets are going to be developed, and it's these engineers. I think it's exciting as well. So there's people that want to be a part of this, and so as we're developing the technologies and we're getting the partners together and we're figuring it out as we go, it's something that the skill set has to continue to evolve with as well. So there's a lot of different. Obviously, there's a lot of college students here, right, that are very interested in software-defined vehicles and wanting to be a part of the industry. It's a future for us. So, it's going to be constantly evolving. We're going to be figuring it out, but I think it's certainly a very important part.
Thank you. Bill, what do you think that what should be done to build the required skills when it comes to virtual prototyping, software-defined vehicles, the convergence of multifaceted skill sets, within the developer, because they understand better, right?
Yeah.
Yeah.
Well, I mean, it's interesting. If you look at the compute problems that are arising with the next generation of vehicles and software defined, it's not just the lower level type of stuff that would even care if they're necessarily running on a virtual prototype with that level of accuracy. Because if you're looking at defining a vehicle display unit or something like that, a lot of the programming tasks there are all that dissimilar from programming any other display. Yeah, there's the safety aspect of that, but there are actually really cool ways of handling this. So you've got your rich display and then your safety display underneath it in case the rich display fails and things like that. So there are a lot of talents that actually will be able to migrate across in there. There are some of the lower level stuff though, the safety coordination and safety as a not just an afterthought but a fundamental part of the flow, as John was mentioning. So to be conscious of that as you go through. But I do see that that's something that's interweaving with the other technologies as well because of the influx of security. I think we've established that almost anywhere there's an attack vector into something, someone's going to figure a way to try and break it in here. So security needs to stop being the afterthought in all this development and be fully integrated into the car, the phone, pretty much almost any aspect now. More and more things are software defined.
Security by design?
Yeah, ideally.
Yeah. Okay. Great point. So when you talk about SDVs and the cloud-enabled development, what are the emerging trends that you see for next 10 years in this space? John?
I had a totally different answer prepared.
Yeah.
But after hearing this, what is now, I truly believe, I started thinking about, code-assisted, AI agents. And where I started going on the track was, people who are early in their career, they're going to get it. You're going to bring, you have this AI who's helping you. But what we're already doing and we're seeing right now is into these AI agents, we're bringing in security concepts. We're bringing in functional safety concepts. So eventually what will happen is the code that is being generated and just your day-to-day, every day of thinking this, you're just going to be hitting all the right points. And it won't be for what we've been pushing hard for all these years. It'll just start coming out. So to me, that's one of the biggest things. And what that affects is the SDV world will go even faster.
Okay. What do you think?
Well, we had this discussion frequently, and I would actually argue that this is the least of the concerns, right? So we had some colleagues who claimed like, hey, and with SDV we can release software 8.6 times faster. That is great, but if you cannot get the software out on the road, it's useless, right? So we really have to look at the entire picture be it the V model or an agilized version of the V model or whatever, and you really have to look at the application of AI across the board, right? So it starts with requirements management, and then yes, of course, faster coding, but then also testing, test automation, and continuous homologation, right? So if we're not able to also have AI-supported continuous homologation, then any speed that we gain on the left side of the V model or whatever you want to call this agilized V model is not going to be useful at all when you cannot basically get it through the KBA in Germany or any other authority.
Yeah, I totally agree. And to me, what I always think is when you have to come back. Right, because of a defect found. So if you can any way to reduce that coming back across the V model, that's the speed. Right?
Yes.
And I agree. We want to code better.
Yes.
And we've heard that. We've heard that for years. I finally feel we can do it.
Thank you. Thank you for all your insights, panelists. I'll open the floor for any questions you think that can add more value to the discussion. Any questions from the audience? Yes, please.
Please wait.
Thank you very much. You pointed out that the collaboration between tier ones and OEMs is crucial for successful and fast development. And what do you think, how much could be the simplification of the supply chains, especially in software and embedded software in the automotive sector, could be also part of the story, because some great players really dramatically reduced the amount of contributors to their software stack. What's your opinion about that?
Well, I don't let me get myself in trouble by starting to make too many predictions.
Okay, you might not be completely neutral on that, yeah.
No, but there are certain, I don't want to sell short for a second the huge amount of technological expertise which exists in tier ones, in here, and their ability to do that. I was merely pointing out the fact that, but if you push off all the requirements for the tier one and wait until you get the delivery back in order to start doing the integration, which is for far too long been the mode of operation, then you're going to fall behind. So a better collaboration model on here, and and basically figuring out how to work better and get deliveries incrementally, or share in that. And of course, if it's me, it's say virtualize that, right? Don't wait until you get the hardware and you've got a virtual version of this, and come up with ways to leverage that expertise. So that is certainly one way to achieve that. I'm not going to claim for a second I have all of them, in here, but that is certainly one method that can be done, and certainly could be very impactful to schedules.
Thank you, Rick.
I have a question that goes probably 3 steps back. I'd be interested in your definition of software-defined vehicles and what cloud-enabled development means in this context.
I'm seeing this a lot, and I think you have at least 2 different types of software-defined vehicle, right? So I think there's the software-defined vehicle, which is actually very close to the embedded side of things. So we're talking about functional safety, hard real-time, and so on. And of course, evolving now into cross-domain functions and so on, right? But that's still, I would argue, within the embedded realm, right? And then the other software-defined vehicle is north of the hardware abstraction layer. And when I talk about hardware abstraction layer, I don't mean abstracting, CPUs or boards. I really mean door, window, wipers, And then north of this hardware abstraction layer, you basically have an SDV that's basically trying to bring in, internet-style processes and runtimes. Yeah, so containers, WASM, whatever. And that's basically what will enable us eventually to actually realize a joint software-defined vehicle that actually can really move at different speeds, right? So everything that's south of the hardware abstraction layer that's got to be first time right. Everything that's north of this software abstraction layer, that can be more experimental. And I think you really have to look holistically at a software-defined vehicle, and of course also at cloud. So it's not a black and white answer, right? So it's not just about software. It really comes back to these bento boxes, and they're different flavors of SDV, I would argue. I don't know if
John wanted to add something.
The reason why we all laughed is we have been in other conferences, and I've heard stories of people getting together, and they had to finally say, "Stop, let's just go to the bar." Right? And these are people who all they do is SDV. But so for me, my opinion is we use software to define the vehicle experience of the occupant. Right? And that's what I was talking about earlier, is when you buy a car, why do we go and try out so many cars? You have to get in, and it has that first feeling of when you get in, what do? You kind of feel the seat. You start driving. Is the color right? It's all about how does the car reflect back to you. But now what we can do with SDVs, if some of it doesn't fit your taste, you can start, can I change it? Can I download something new? Right? Now we can change it as we move forward. And then cloud software development, there's layers. Right? Think of a software stack, application, middleware, driver, go down. With working in the cloud, application and middleware, developers, they don't have to wait. They don't have to wait for anything. They can get going. And the technologies that are all being actively worked on today in software are, so the application developers, they don't care. They don't know what's underneath. They don't need to know. Middleware, they don't need to know. But as you start getting lower, they do start needing to know. But that integration pipeline is now, starts really, really early and just gets simpler as we get further along. That's the...
I think if we combine these two perspectives, and actually we do continue discussing this with a German beer, then this is pretty close to the truth.
Yes, I was going to say the conversation does not stop at the bar. It just gets more colorful. So,
in simpler terms, that if you want to upgrade your car, the software, you can do that on cloud. You don't need to set up the appointment after a few weeks to go there and take it to the maintenance, right?
Yeah, to me, I want to go back to the subscription services, because I do not like it. I'm probably going to get in trouble for saying that. But
just to jump in, so cloud enabled for you means remote software update. So it doesn't mean it doesn't mean you have a joint development of various different entities in the cloud. I mean, in the cloud, open source or whatever. It simply means remote software update.
It means all of it.
It's one of the use cases. It's one of the use cases for a remote software update. Yeah.
And that's kind of the problem of this topic, is there are so many angles and so many ways to come into it. But I would agree with what you said as well. Okay. It does mean that. Yeah.
Yes.
Thanks for the inspiring discussion. I have one doubt. It took us over 20 years to develop development process models like Automotive SPICE, which we are all eager to follow, and with a lot of audits and stuff and normative influences. And they are always a little behind the reality. And now we end up with the picture that you drew here. And what will be the consequence for these model shaped and very embedded minded development process models, and of course the structure of the companies who are the players in that? What will be the influence?
Oh boy. That's a loaded topic.
That without the beer, come on, that's tough.
It's about the agility, because standards, when you talk about industry and academia and these standards, right? Industry behave from a user perspective, that what the user wants, right? And we talked about agility in the model, we talked about design principles and everything, right? So that drives the business model innovation for the companies, right? Standards follow, because as you move forward, as you do drive different initiatives, you identify that, okay, this is a bug, this is an area where we can build a process, we can build a standardization. So it takes time, it goes hand in hand, but Yeah, I think, what do you think, Bill? I think you wanted to.
Well, it's interesting. There are a lot of areas where there's a lot of adherence and and driven by standards, and that certainly has been how things have traditionally been done. But then you go to China, right? Entirely different set of standards, entirely different development methodology, and if you look at a place where SDV is thriving, it's China, right? They're breaking the mold on that. They're not adhering to the standards. Now, you can certainly read the horror stories of the cloud-enabled car that they all stopped working when the company that sold them went bankrupt. And little things like that, that certainly come into problems. But you see where a lot of the the norm is being taken and shaken upside down. It's in places like China where they aren't constraining themselves with legacy regulations. And I think you ignore the success of the advances that they're doing there at our own peril. Not saying that we should suddenly tear down all the regulations and blindly follow them down there. I'm saying though that that they're certainly doing that. They're innovating, in here and adopting some of the approaches and such that they're doing is probably a good way to do it, while still finding a way to coexist with it. At least the stuff that makes sure we don't die in the process.
Great point, Bill. Yes, please.
I think when you mentioned verification towards the end, that was the first time I've heard it in 3 days. The speed of the software that you're talking about coming on SoCs is very scary. And regulation is one thing, but basic verification is something different. How do you think cloud-enabled development will help mitigate the kind of the challenge for verification that's here and it's coming?
To me, if you can make verification interesting and fun as part of the development process. I remember when I was coding a lot, coding was fun, verification not so much. But then the new, verification framework started to, arise that interested me. And then I was actually trying to think of me, it's a long time since I've had a code. I found it was interesting. So what I was doing was I was adding code. I was adding unit tests, right? And then I noticed I was getting less bugs. So with virtual platforms, working in the cloud, the test cases that you can run they're hardly limited anymore. Maybe your comptroller, your accountant might walk in and say, why are you running so many cloud cycles on you? But you could then map it back to, I'm running more test cases. I'm, have the ability to, use all my intelligence that I am motivated to go do because I can see it. I can see the output really quickly. And my limitations and restrictions are much, much smaller.
Yeah. As soon as you lower the barriers for adoption here, you put something in the cloud, it's much easier to get to. It's much easier to program to. It's much easier to interface to. You get people more interested in doing more things with that. It's interesting. I've got one of my solutions architects has no automotive background at all. He has a he has a mobile background in here, but we've got him doing our stuff with this, and the other day he brought up one of our virtual ECUs and discovered the CAN bus, and here he'd never played with it before. So he started assembling all of these various systems and pulling things together in ways that he saw the building blocks and started playing, with these things. He managed to find a bug in one of our models as doing all this. It's by subjecting it to these and basically, like going back to John's thing, making it fun. And here we actually did that. But fundamentally, we're enabling more cycles to be run, enabling more tests to be run, enabling them to be run continuously. If you can scale up the size of your CI/CD farm based upon, as you get more tests and basically say, oh, I actually need 1,000 of these to run now. Well, you can't go from 10 to 1,000 real boards very easily. In the cloud, it's just another API call in here. So that's going to enable you to greatly up your verification throughput on here, throw more tests at here, and adapt some of these more modern techniques, fuzzing, et cetera, like this, to now come up with a much better verification methodology.
And there are test automation frameworks as well that can help to accelerate that testing as well for verification and validation for the different targets. So you can definitely execute that so you have more better, faster results of what you want to do, execute. Yeah. Any more questions from the audience? Yes, yes.
I have a remark to that. I mean, in the past, the testers ironed out the flaws of the coders, and the coders ironed out the flaws of the architects, and the architects ironed out the flaws of the requirements engineers, so everybody could rely on the next step in the V model to get rid of, let's say, early errors. And now with STV and what you have discussed, I think we have despite of the marketing potential, we have a great potential of this real shift left, so that we have good requirements. I mean, this is the problem in general, and with all the AI and LLMs and Gen AI in the chain, in the tool chain, we need to get much more focus on the requirements, and I think that STV can help a lot of doing that.
I agree, definitely, because requirements is the base, it's the foundation of any STV. You talked about, different stages and people rely on different teams. I always believe in peer review. So yeah, the teams need to converge again. A different team needs to validate and say that, how this can add value earlier in the cycle. What do you think, John?
That's exactly what I was thinking. If you can do this early, then you can feed that mistake or discovery of an unintended feature back up the chain much earlier, and then it can be fixed and then move down even further, and then keep feedback down, feedback.
Yeah, so different iterative feedback loops helps design, develop better vehicles for the future. Yes?
Yeah, I know we are moving towards from distributed architecture, then zonal architecture, and central vehicle computing, something like that. So are we directly going to replace all the ECUs with this high-performance computer, or it's kind of if there is any error, still this ECUs will be there as a fallback mechanism, it's still available, or we are directly going to replace it? What is the initial strategy the industry is going on?
It's a future question, but any insights from you, John?
Yeah, we see this a lot, and where the natural progression, it happens in everything. It's going to end up to be a balance, right? Things that can be moved from the external peripherals, functionality that can be moved to the HPC will happen. But if that cost of that move, if it is too high, it won't happen. So it's going to be a balance, but there will definitely be consolidation.
And I think it's an organizational question, right? Are you starting on a green field or are you starting on a brown field? That really is key.
Yeah.
Okay, so still there will be some fallback ECUs will be still present as a current architecture. That means we are not going to completely replace. Still there will be some fallback ECUs, like if you have the steering system, if there is any error, then there should be some fallback mechanism, right? This actuation part directly will not control from the HPCs.
It depends. Sorry, I had to answer it that way. But yeah, you're seeing what is being asked everywhere is how much consolidation can you do? Because eventually, because of the physics and the response time that you have to have, and the level of safety that you have to have, that's going to define the answer. And really, it's almost on a case-by-case basis. You'd have to answer that. But no, you cannot go 100% everything to the HPC and only have your sensors or your actuators on the outside. Not in my lifetime, probably.
Yeah, thank you.
Okay, I think we have a question.
Are you going to make them run all the way to the back?
Yeah. Okay. So thank you, panelists. I think it was a very interesting discussion on the future of cloud-enabled development of software-defined vehicles. We talked about cross-system integrations, cybersecurity, compliance, OTA updates, and everything. So let's look forward. I wish you all a good event. Yeah, enjoy the rest of the day. Thank you.
Thank you.
Thank you.
Thanks, everyone.